Welcome. In this video, we're going to take a look at angles and understanding radians. So first off, I want to apologize for the fuzziness of the picture. Hopefully my explanation is much clearer than the picture. So just going to focus in on this middle circle here. Typically we think of angles and we think of degrees. Okay, and we know there's 360 degrees in one circle or one revolution. And so if I start here with my angle, if I go around all the way, that'd be 360 degrees. If I go halfway around, that'd be 180 degrees, and so on. And so we can keep chopping this up 90, and then we can divide this whole thing into 360 little pieces, and each little piece is an angle. Now, we're going to find that it's much easier and much more useful at times to use what we call radians. And radians is just another way to measure angles. Instead of using like little pieces of the circle to do it, we're actually going to build off the radius. So I've got three circles here. Each has a different radius, a different size radius. If you look here, I've got a little piece of wire that I've cut to equal the radius. And so if we take these little pieces of wire and bend them, we can then wrap them around the circle. And so the question is, how many radiuses, or the correct way to say it is radii, will it take to go around the circle? Well, you can see I've got 1, 2, there's my third one, 4, 5, 6 or so. Let's take a little closer look. Get these lined up a little bit nicer. And you'll see we've got a little gap here. Oops, bumped my paper. We've got a little gap here at the end. So 6 and a little bit more radiuses to go around. The cool thing is, if I did the same thing with the big circle, now I'm not set up for it, I'd have to have longer wires, right? And since I have longer wires, it would still take exactly a little over 6 to go around. And if we did some calculations, to go all the way around would be 6.28 radii, or radiuses. And here it's the same thing. We could do some calculations and find that going all the way around is 6.28 radii. And if we did the same thing for this little circle, cut small radiuses and then bent them, it would take 1, 2, 3, 4, 5, 6.28 radii to go around the circle. So instead of chopping the circle into 360 little pieces, 360 degrees, and counting degrees, instead we can count radiuses, and that's exactly what radians are doing. It's angles measured with radiuses. Now you might be thinking, why would we want to measure with radiuses? Well, here's a hint. If I take these away and I look at how many radiuses does it take to cover a semicircle, you can see it's just over 3. In fact, if we would divide 6.28 by 2, we would see it equals exactly 3.14159, a number you're probably familiar with as pi. So when we're working with radians, it takes pi radians to go halfway around the circle, which is 180 degrees. Now, I want you to pause and really think about that for a minute and realize how amazing that is. Draw a circle, any circle. It can be this big circle in the center of a basketball hoop court or basketball court. It can be a roll of tape. It can be whatever your circle is. I don't care what. Mark out the radius, cut out 3 radiuses. bend them around the circle, and it will always take 3.14 radiuses to go halfway around the circle. Now, this is what we're going to use in the future with radians, and we're going to use this key that pi, which is 3.14, is equal to 180 degrees, halfway around the circle. So, quick summary. Basically, radians is a way to measure angles by counting the number of radiuses it would take for that angle. So if I look at this angle here, this angle is a little under 2 radians. All the way around the circle is 6.28 radians, halfway is 3.14 radians. And we are going to use those angles in the future.